So a neutralization reaction is a reaction between an acid and a base. You may think of acids as kind of the opposite of a base, and when they're in contact with each other, they're going to basically completely obliterate each other. It's kind of like one is a superhero and the other is a villain, and when they come together, they're just going to completely destroy each other. In general, when an aqueous acid-base reaction takes place, it's going to produce water and a salt. Now, the word salt isn't just referring to sodium chloride, that is table salt. It's referring to an ionic compound, something that's made up of a cation, that's something with a positive charge, and that's usually a metal, and then an anion, which has a negative charge, and these two things will come together and form that salt. So let's look at an example of an acid-base reaction. We have hydrochloric acid, that's this thing right here, is reacting with sodium hydroxide. Now, usually the thing that starts with an H is going to be the acid, and then the other one, the base, will generally have OH at the end. Now, the H from the acid is going to switch places with the metal, or the cation, that's in front of the base. So H will bump out the sodium, and the sodium will move over here and combine with the chlorine. So in this reaction, we're going to end up with the H combining with the OH, and so we'll end up with something like this. But we can rewrite this a little bit better way. We have two hydrogens, so we could just say H2O. That's where the water comes from. The sodium will combine with the chlorine, and that's going to form the salt, so we end up with water and salt. Here's another example. Now, in this example, we have a diprotic acid. That is one with two ionizable hydrogens. That's this right here. So this is sulfuric acid that's going to react with potassium hydroxide. The same thing's going to happen where we'll have the hydrogens switching places with that metal that's in front. And it's going to be really important that we remember that we're going to be producing ionic compounds. So in other words, things that have positive charges and negative charges. The charges within a compound have to balance each other. So the total number of positive must equal the total number of negative. So when hydrogen is an ion, it's going to have a plus charge, H plus. And when hydroxide is found alone, it's going to have a negative charge. So since I have a positive 1 and a negative 1, those balance each other. So I only need one hydrogen ion and one hydroxide ion. And so that's where this H2O comes from. Now you may be wondering, well, where does that extra hydrogen come from? We have one here and we have two over here. So that's a total of 3 hydrogens, and I only have 2 listed on this side. Don't worry about that yet. We'll balance this thing at the end, and you'll see how all that works. Next, we have the potassium, which has a +1 charge. And I know potassium has a +1 charge because I can look at where it is on the periodic table. It's right here in group 1, and everything in group 1 is going to have a +1 charge. That's why hydrogen also has a +1 charge. And then sulfate is going to be the SO4 part of it. Now, this is a polyatomic ion, and there's a list of polyatomic ions that you really should memorize, or at least have a list available. SO4 has a 2- charge, and so we have to get these two charges to balance out. I'm going to have to add an extra potassium in order to get a total positive charge here of 2+ to balance that 2 negative. Okay, and so I've written that formula right here, showing that there's 2 potassiums, K2SO4. Again, you may be wondering, well, where do we get that extra potassium when we only had 1 over here? So the next thing we can do is we can go ahead and balance this chemical equation. When we balance the chemical equation, we're going to change the coefficients that are in front of each of these symbols. Right now, there's nothing here, and so that just means there's 1 of each. So we're going to adjust those values in order to balance this. So first I'll start with the potassium, and I'm just going to add a 2 right here in front of that, and it's going to multiply everything here by 2, and so I have 2 potassiums now, which balances this on this side. And then I have a total of 2 hydrogens, because that 2 multiplies that by 2, plus these 2, so I have 4 hydrogens right now. I'm going to go ahead and add a 2 on this side, which is going to balance out those hydrogens now. I'll have 4 on this side and 4 on this side, and then everything else will be balanced. I have 1 SO4 here, one of those SO4s over here, and then I have these two oxygens with these two oxygens.